Hola, my name's Terry and I'm sitting here at the workstation where John and I have been working on the Plasmic transmission process engine. Well, one of the important parts is our fuel mixture. And one of our important parts is our fuel mixture. Well, to be able to do that, we're using microprocessors, we're using C embedded coding, and we've developed. John had developed before one of the boards for the mixer, an older outdated one. And this is a new up-to-date. I've stuffed, worked, and checked on this board here. We're using C programming. John has helped me set it up, and we're able to use the sequences for this machine right here. This machine is something we're very proud of, and it's something that we very much needed. This can mix our fuel down to the cc's. Pretty precise if we do this right. We're doing microseconds and down to the cc's for our measurements. Now this machine here does quite a few things. It does three major things. As you can see, the gases are all sitting in here. They all have regulators. They all come up to these electronic valves. And these are pretty precise and does pretty precise measurements. Let's say for the moment here, I'll hit one of the buttons for the programming. As you can see here, these are powered to the solenoids, the electronic solenoids. Each one of these gives us a spurt of a certain amount of fuel. Those measurements are done by the microseconds. And we're able to control these, and then we're able to mix them. Now a lot of these gases you guys are familiar with that we use as fuels. We have helium, argon, neon, krypton, xenon. But anyhow, these are some of the fuels that we use to get the mixture that we need. And this was something that we needed to do. Okay. Also, we have functions on here that will give us a load up of certain gases we might want to flush our engine. And we can flush the engine out. Also, we have settings on here to mix our fuel and to also flush the engine and to fill the engine. And we're in the process here would be filling. This right now is designed off 12 volts. As you can see, the master board is sitting in here. And not only did I do the soldering on this, but we did all the checking. I was able to do the wiring, and also we did all the hookups. This was something we built pretty well from scratch. It's on a cart where we can wheel it around, and when we're ready, we'll be able to fuel these engines easily and precisely. This is something that has took a lot of time, a lot of energy that had to be done, and John has really helped me in a lot of these boards understanding the process and in the coding and the embedding and how to use these microprocessors to build things that we need to do. Now this information will also be used to understand the motor and help us get the motor back on track from things that we're working on. Thank you.
Does that mean you're going to be able to come up with the same fuel mixture as was used in the 2013 running engine?
We should be able to easily...
Why didn't you say that?
Why didn't I say that?
Yeah, you just said, well, we're going to make this mixture. You all know what that is. No. We're making a mixture just like the mixture we used in the 2013 running engine.
Oh, I didn't say. Okay, so tape. Okay. We will also be able to use this item to not only mix the fuels, but use different types of mixture to the ones that we have tried and possibly different ones that we might want to experiment with. So this machine is going to do what we need to do. We needed to build it, and we do have it. We definitely have some more testing to do and some more spreadsheet work, but we do have her down pretty precise on cc's and liters of the type of fuels that we need. Yeah?
Still no reference to the original engine. That's okay.
From the, not to the original mix, you're saying?
To the original mix from the original engine, yes.
Well, you always said that wasn't super important. That there was quite a few mixtures that would work. So I wasn't for sure.
Terry, the mixture you're going to put together is the same mixture as we used in the 2013 engine. And for some reason you don't seem to think that's important.
Okay. Okay.
Do you understand what I'm saying?
Yes, I got it. I know what you mean. Okay. Tape. Okay, one of the things I want to explain also in this is one of the reasons we're working so hard on this to get these measurements so precise so we can get the measurements back to what we had in the engines in the 2013. And then also we'll be able to use new mixtures if we choose to, or we can mix to the older mixes of items that we did have. Something like that.
Okay.
That basically said that.
It's just your reference is the 2013 running engine.
Well,
Now-
to the mixtures of that engine, is what I said, that we can mix the fuels in
Yeah,
those mixtures.
well, that's what your reference is. Okay? It's just one of those things that, you know, when you referenced the fact that you're working on a plasmic transition engine.
I didn't say that in this one, did I? Did I?
I don't know.
Well, okay.
It doesn't make any difference. I'll take it home to you.
Okay. One of the items that we're doing, and one of the reasons we're doing this, and why this is so
One
important.
of the items,
Okay.
we are working to recreate the plasmic transition engine from that was available in 2013 and now is illegal in the United States.
Let me say, okay.
That's 2 words.
One of the reasons that this is important is we need to be able to mix these fuels, and we're trying to mix them and have the same mixtures that we had in 2013. This was at a time of some of the engines that we worked on that we felt had the best mixtures of what we need. And now we have the equipment to be able to do that. So this has been a very important step and will help us tremendously move on to the next step.
Yeah,
Something like that.
all right.